Evening, everybody, and welcome to tonight's Facebook live stream from Drayton, the last training session that I'm going to be doing of this year. And tonight we are going to be looking at, as you probably saw from the promo, we're going to be looking at the 𝗿𝗀𝘁𝗲𝗃 underfloor heating controller and also the electrical heat switch. Now, these have been out for a while now, so a lot of you have started to fit them, and we seem to get the same questions coming up time and again. So I thought I'd take this opportunity to address those and hopefully make your life a little bit easier when you actually are installing these. Usual sort of format. I've got a sort of a bit of a presentation to show you, but if you want to interject at any point with any questions, we'll pick them up, and it's really just an opportunity for you to ask any relevant questions about these products, anything that you've been struggling with when you've been trying to fit them. So I'm going to dive straight into it, and we'll begin by I'm going to show you it on as a slide here. Let me just bring me in so that it's a little bit more personal. Right. Okay. So I'm going to do it as a slide because it's quite difficult to actually get some close-ups on this, because I'm sure you appreciate if you try to wire one of these, the terminals are quite small. So and in fact everything in them is quite small. So I'm going to do it as a render so that it makes a bit more sense. But just to give you a bit of an overview, if you haven't yet fitted these and you don't really know what they're about, this is the 𝗿𝗁𝘁𝗲𝗃 underfloor heating controller, and it's designed to replace your existing underfloor heating wiring center. So typically you're going to have a manifold with some amount of thermal actuators on it that will wire back to a wiring center. And also in that wiring center, you're going to have connections for your pump and your boiler or motorized valve, but you're also going to have all of the wired thermostats coming back to this wire to your existing wiring center. Now, this takes the place of that, and you've got areas for your thermal actuators to wire in. So each one of these strips will handle up to 14 thermal actuators, which can be split over 6 zones. So you can have if you've got multi-loops, so if you've got more than one loop in a particular zone, you can wire them all into the same zone. So that's your zones across the top, your 1 to 6. Each one of those would have a 𝗿𝗁𝘁𝗲 room stat assigned to it, and then that room stat is going to control the bank of thermal actuators that are wired in below it. Now, because those 𝗿𝗁𝘁𝗲 thermostats are wireless, you've got a lot less wires going into this than you would with your existing underfloor heating wiring center, because obviously they tend to be wired, so they'll wire back. So you'll end up with spare wiring for your existing underfloor heating room stats if you're retrofitting this, or if this is a new installation, it saves you the bother of having to run loads of cable from each room stat back to the wiring center. So it does really simplify it. Now, most people are fine with that. They understand where the thermal actuators wire back to. It's more sort of the right-hand side. So if I go to the next slide, this tends to be where where there's a bit of confusion. So if we start on the extreme right-hand side, those 2 terminals, that's your mains power in. Now, this is a class 2 device, which means it doesn't require an earth. So you can feed it with a 2-core cable. It does require a main supply on those first 2 terminals, but you can see then from the sort of wiring diagram that's etched on the casing that the live and neutral is bused to other things. So as well as when you feed those 2 terminals, as well as actually running the stat, it's actually linked in the side to some of the other terminals. So if we move towards the left, you see you've got N2 and L2. Now you can see that those are just linked directly to the incoming main supply. So that gives you a neutral and a live that you can connect something to. Now, what are you going to connect to that? Well, you've got options. So the very next 2 terminals, which are B1 and B2, that's your interlock. So that's the contact that goes live, or it makes, I should say, that contact makes when any one of your room thermostats that are assigned to your 1 to 6, if any one of those calls for heat, so any one of those zones calls for heat, the bank will fire. That will drive the thermal actuators, and it will also make that contact. We call it a boiler. It's a boiler relay. It's an interlock, and it can go off to drive something. So what we're basically saying is if there's a call for heat, as well as driving the thermal actuators, we also have got this contact which can go out to what it would typically do is fire a motorized valve or drive a motorized valve open. But the important thing is that it is volt free. So you can see from the etching on the casing there that B1 and B2 are connected together via a switch, but they're essentially volt free. Until you bring a voltage onto B1, you're not going to get anything out of B2 and when the switch is made, unless you bring something onto B1. Now, what you would typically do then is L3, that terminal that is linked to the mains in, you can take a live from that, put it onto B1, so a little loop of wire inside there, and then that will mean that you've got a live output that can go out to fire a boiler or maybe drive a motorized valve. Normally, you'd have a motorized valve on the incoming side of the manifold, and you would drive the brown wire of that, so that to actually drive the valve open, that the valve then will permit flow into the manifold, and the internal switch in the motorized valve will fire the boiler. But you don't have to do it like that. You can have it go straight off and fire a boiler, or because it's volt free, you can bring whatever voltage in. So if you don't want to be switching mains, you can bring 24 volts onto B1, and then 24 volts will go out on B2 when the switch is made, or whatever voltage you want. But that's why you might need to move voltage around inside the underfloor heating controller, and that's why you've got that terminal, that L3 terminal, as well as the N3, which is just it's just linked to the incoming supply. Now, if we move further left again, this is where your pump that's situated on your manifold is going to connect. And again, it's the same sort of principle here where it's volt free. So when you look at that wiring diagram there, they're not linked to the main incoming supply. And the reason this is because you can typically your pumps are going to be class 1, so they're going to require an earth. And if you've only fed this with a 2-core cable, there's not going to be an earth there. So this gives you the opportunity to bring a separate live in for your pump of a cable that's got an earth in it and is of an appropriate size to match to the pump that you're running. So you can bring a live in, and that would go on N1, L1, and then one of your earth terminals in the middle there. And then the outgoing to your pump would connect to the other side, which is the earth, N2 and L2. So the thing to remember here is if you want to run a pump on your manifold, which you invariably will do, as well as connecting the pump tail up to N2 and L2, as well as the earth, you also need to bring voltage in onto N1 and L1 in order for it to run, because it is volt free. Now that catches a lot of people out because they find that the pump doesn't run, and it's because unless you bring something in on the supply side, you're not going to get it going out on the other side. Now, the reason you want to run your pump this way is because there is built-in pump overrun on the underfloor heating controller. So when the call for heat on the last active zone ceases, the interlock will break. So that means the motorized valve or the signal to the boiler will be interrupted, but your pump will carry on running just to get some of that hot water evacuated through the manifold. So you do want to use it, but just be mindful that you can't just connect the pump tail up to it. You need to bring a separate live in, or this is again, if you're not using N3 and L3, you can use that you can link across to that. So a loop of wire, N3 to N1, L3 to L1, and then N2 and L2 go out to your pump. But just be mindful that you would need to be bringing an earth in on your main incomer. Then your supply would need to have an earth wire. It would need to be a 3-core. Otherwise, you're going to end up with an unearthed pump, and obviously we don't want that. Right, so now that's really how you wire it up. Now, in terms of the process flow for when you're fitting it, so what you really want to be doing is, remember, hub is the center of your system. None of this stuff's going to work unless you've got a wiser hub, but that's the first thing that needs to go in. So you'll wire that in, and remember, as soon as that's powered up, that will broadcast the devices network that you can then add the devices to. The next thing that you would add is the underfloor heating controller. So before you put the room stats in, you want to get the underfloor heating controller in, or multiples. Remember, you can have 3 of these per hub. So if you're doing a big underfloor installation, you can have 3 underfloor heating controllers per any hub. You need to get that in next. So hub in first. When you're going then through on the app, first thing to add is the underfloor heating controller. And then the second, once that's in, you can then start to add your room stats. And the reason you need to do it in that order is because when you add the room stat, then it will ask you, do you want it to be controlling the radiator circuit, which would be the relay in the hub, or do you want to have it controlling underfloor heating? And then if you expand on that, it will then show you, ask you what channel you want. And I'll show you that in a minute with how that looks in the new app. But just in terms of a process flow, once your hub's in, get all of your underfloor heating controllers in, and then add your room stats, and you'll be able to address them properly to their appropriate zones. So now to the new app. Now, I'm sure you've probably seen that there's been a lot of updating going on recently. Not least, we've done a new version of the app, and it's got a slightly different look, but it's also got a different process flow depending on whether you're installing it as a homeowner or as a professional installer. So once you download the app now, and it's always a good idea to make sure you're on the latest version of the app to make sure that you're not going to have any issues when you come to install this. Exactly the same principle as before, where you want to be owning the installation. So you don't want to be asking to use the customer's phone. You want to go in and do all the bits that you need to do, driving it on your phone. Once you're happy with that it's ready, that's when you can then hand it over to your to the customer. Just makes the process much more elegant. You're not asking to use the customer's phone, and also you haven't got the customer sort of hanging on your every word when you're asking them, can you do this, that, and the other? So you can own your bit, drive it with your phone, and then hand it over to the customer. So Get Started is the button that you'll click once you've downloaded it. This is the new screen that you're faced with, whether you go in as a homeowner or a professional installer. If you pick homeowner, it will drive you through the registration process, where it's going to need email addresses, passwords. It will send you the email with the confirmation in. So the same sort of journey that you would have been on before. But again, if you're going in fitting this for a customer, you don't want to be getting involved with that. So the professional installer button is what you will choose, and that will then guide you through the setup process. So you'll pick your region, your location. So we'll pick the UK here. We'll then pick what we're fitting. So remember the 𝗿𝗲 app, the 𝗿𝗲 Home app now covers 𝗿𝗲 as well as the new 𝗿𝗍𝗁 with the Bluetooth connection. But here we'll pick the hub. Usual thing, press the setup button, just a quick click to get the green light flashing. Progress through. That starts the soft access point that you can then pick up in your Wi-Fi settings. So in here you see there's an access point now called 𝗿𝗲. You pick that up, wait for it to stabilize, whiz back into the 𝗿𝗲 app. So just background your settings and foreground the 𝗿𝗲 app. Continue button now has gone green, so it allows you to progress on. You get the confirmation that you're now connected to the hub. And this is essentially where you've always been before. This is how you've got your phone talking directly to the hub without the need to connect to any Wi-Fi or anything. So you can configure here the type of boiler you're fitting into, or even if it's a heat pump. It then prompts you, do you want to connect to home Wi-Fi? No requirement to do this if you don't want to. And if there is no Wi-Fi, you can't do it anyway. So you hit skip. The app will always prompt you to say, are you sure you want to do this? Because by not doing this, you're not going to have things like remote access. We're not bothered by that because that's very much in the homeowner's domain. So we're happy to skip that. You then get to the devices adding page here. And this is where, like I was saying before, when in terms of the process flow here, even if you're building up a system that's going to have room stats, radiator thermostats, underfloor heating controller, and electrical heat switch, here you want to be getting the underfloor heating controller in first. In the same way as if you're fitting smart plugs as well. Remember, the smart plugs, as well as being able to control what's plugged into them and monitor the energy that's being used, they also are range extenders for the device's network. So if you're going to fit any of those, you want to get those in first. But it's an absolute must to get the underfloor heating controller in first, because you need to get that in before you start adding room stats. Otherwise, the room stats don't know that it's coming, and therefore you can't address them to the 6 channels per underfloor heating connection strip. So we'll pick underfloor heating controller, and it tells you to press and hold the setup button on that until it alternates green. So once you've done that, the device joins. You get to give it a name, and the reason we do that is because you can have multiples. So these may be set per floor, or if you've just got one, it doesn't really matter what you call it. Here, I'm just calling it underfloor heating controller. And you then get to choose: do you want to use the relay that's built into it? So that's this little interlock. Remember the one that's volt free that are on terminals B1 and B2. So you can either choose to use that, or if it's more convenient, you can choose to fire the relay in the hub. Now here, I've got this connected to a 𝗿𝗁𝗁𝗃3. So it's got the 3-channel hub. So you get the choice between channels 1 and 3. Remember, channel 2 is always designated as hot water. But you can choose here whether, if there's a call for heat on underfloor heating, do we fire the relay in the underfloor heating strip? Now, typically, I typically find that's what I'm using. I'm not firing the hub. The hub may be in an airing cupboard somewhere, but the motorized valve tends to be, or for the underfloor heating, tends to be right on the higher side of the manifold. So it's normally that I'm going to be using that to drive that motorized valve open. But if the architecture is such that all of the zone valves are in the airing cupboard, you don't have to run a wire between the underfloor heating controller and the zone valve. You can just elect to fire one of the relays in the hub, and that saves you the grief of having to do that. So once you've done that, you then get back to this landing page, and I'm sure if you fitted 𝗿𝗁𝗁𝗁𝗃, this will be a familiar site for you. So you'll be back to this landing page for as many devices as you need to add. Once you've added that, though, that's when you can start getting the room stats in. Because remember, that device in on its own isn't going to do anything until you've got some sort of temperature sensing. So usual route for adding the room stats. So the app tells the hub to expect to see it. Pop the batteries in. It goes straight into join mode. The device joins. You then get to give it a name. So this is going to be the name you give it will be the room that it's going to go in. And then because we added the underfloor heating controller first, we then get this additional menu where you can see you can choose to control underfloor heating or the radiator circuit. So if you pick underfloor heating, it then expands out that menu and you can choose what channel on the underfloor heating controller you want to control. Now this is a drop down that you can scroll through, but the important thing is here you don't just scroll to it and then move off. You actually have to click it to bring the little tick up next to it, because you can choose to have multiple zones controlled by the one room thermostat. So when you go in there, scroll to what you want, and then remember to click the zone so that you get the little tick. That will then assign it to that zone. Once you're happy that that's set up how you want, you progress on, submit that, and then you're back to the landing page that you're all familiar with to add your next room stat. And obviously you'll add as many room stats as you've got underfloor heating zones that you want to control. So that's the underfloor heating controller from 𝗿𝗁𝗁𝗁𝗃. Now I'm just going to quickly cover off the electrical heat switch. I don't see any questions that have come in. Let me just double check to see if there's any questions that have come in about that before I move on. Not seeing anything, but this session's probably going to go on to about 7:30. So you've got about 10 minutes to get your questions in if you've got questions on anything you've seen so far, or indeed what's going to come up now. So I'm now going to move on to the electrical heat switch. So again, the overview here is this is actually showing you the internals of it. I've not got a shot of it. That's what it looks like from when it went on. That's how it's going to look when it's on the wall. So it's designed to control electrical heating loads, or it's really allows you to bring electrical heating loads onto the 𝗿𝗁𝗁𝗁𝗃 platform. Now you may say, well, why do I want to do that? Because if I've got a panel radiator, it may be that it's already got onboard controls, or they may even have smart onboard controls. But the reason why you would want to use this is, firstly, it brings it all onto the same platform, so you're not having loads of different apps to control different things in your home. But also it allows 𝗲𝗍 to see the energy consumption, and this is what 𝗲𝗍 is really all about. As much as it's a heating control, it's moving towards being a home energy management system. So the more significant loads that are in your home that you can have controlled by 𝗲𝗍, it gives 𝗲𝗍 a much better picture of what your energy consumption is. And then obviously once we know what you're using, it can then manage how you use that, and link it to, if you use things like Insights Plus, it's linked to your smart meter, so it pulls tariff data, and it really just gives it the opportunity to be able to use energy in the most effective and efficient way. So that's the reason, or the rationale behind why you want to get a panel radiator or electric underfloor heating or a plinth heater onto the 𝗲𝗍 platform. As well as control, it's also the energy management and monitoring. So if I zoom in a little bit on that, this is the bit that we're interested in, the terminal rail. Couldn't have got a worse photo of that by the looks of it, but you can just about make out what's going on there. But these are essentially an inline switch. So you're going to have your fuse spur that's feeding the load, and you're just going to interrupt the line between the fuse spur, the supply, and the load through the electrical heat switch. So on the left-hand side, we've got our live out. So that will be, so it's essentially a single pole, single throw switch. So we're not switching the neutrals, we're only switching the live. So first terminal on the left there is your live out. So that will be out to the load. The second terminal from the left, live in. So that is the supply in. The FP terminal is for a pilot wire. We don't actually support that in the UK. Some I believe it's quite popular in France. But we don't use the pilot wire connection in the UK, so you're never really going to connect anything to that. The next two terminals are your earth terminals, so just two earths linked together. Obviously, no switching because it's your safety conductor. Next two terminals are your two neutrals. So again, doesn't matter which way you connect these up because they are just two terminals that are linked together for your neutrals. And then the important terminals, if you're using this for electric underfloor heating, is the sensor connector on the extreme right there. So for panel radiators, you're not going to be using that, but if you're using the electric underfloor heating, it's mandatory that you include a floor sensor. Now, the floor sensor is not designed to call for heat. It is designed to be a limit, so it makes sure that your floor doesn't overheat. When when there's if anything goes wrong, or if the room starts calling for heat, it just means that you're not going to have any injury by overheating the floor. So you would still use a room stat to call for heat, but the sensor there is just to make sure that if anything goes wrong, or that the floor has not got the ability to overheat. Because if you think about a wet system, that's governed by the boiler stat. So it's not so critical unless you've got a floor covering that you care about, that you don't want to over or underheat. It's not so critical, and that's why it's not mandatory for a wet system, because even if the stat is set to 30 degrees, the floor is only ever going to heat to what the mixing on the fundamentally your boiler stat, but it goes through the mixer on the manifold. But obviously with this, as long as you give it electricity, it's got the potential to heat. That's why you've got your sensor. So this is the sensor. It's not a particularly interesting thing to look at, but it does do a good job for what it does. It's a 33 kiloohm sensor. Now, the rule at the moment with the electrical heat switch is it is only compatible with our 33K sensor. And that's really just because we need to do more testing on third-party devices to make sure that they are safe to use. So if you're using the electrical heat switch and you need a sensor, then you will need to use our sensor, which is available in the Priority shop if you're 9 Degree Network, or in your merchants. Now, it's the same sensor that you use for the electrical heat switch and the underfloor heating controller. So here you can see on the underfloor heating controller, the extreme left-hand sensors, you've got a limit stat, which is your first two. That's terminals T1 and T2. That's where you would connect that. Now, it only does one zone, so you would need to choose which zone you want the limit stat to be active on. But it's the same sensor, it's the same 33K sensor that you would use on the underfloor heating controller as you would the electrical heat switch. Incidentally, the two terminals next to that on the underfloor heating controller, terminals D1 and D2, that is for a dew sensor, and that's if you're using it in cooling mode, which are the next two terminals, which are C1 and C2. Those two, if you put a 230-volt supply across those, so it sees a 230-volt signal, that will drop the underfloor heating controller into cooling mode. That's where you get that snowflake come up on the device. It inverts the logic, so instead of a set point above ambient being a core for heat, it would be a set point below ambient would be a core for cool. So, but obviously you would need a heat source that supports cooling, so that's very much aimed at your heat pumps. So it's going to be the heat pump that drives those terminals. But if you do that, if you run it in cooling, obviously we've got a potential condensation problem there. So you would need to make that's where the dew sensor comes in, goes around the manifold. As soon as it detects condensation, it throws the system back into heat mode to stop it cooling any further. But it's the same probe used for both. Now, I can see some questions coming in, and I'll have a little read of those in a minute when we get to the end. I'll just get to the end of this little thing where I'm going to show you how you add the electrical heat switch. So again, from the device adding device pages, you'll choose the electrical heat switch. And again, the electrical heat switch works with a room stat. So you want to add this to the system first before you add the room stat, so that you can address that room stat to this device. So add it in, follow the prompts through. Once it's added, you then get the option here to assign the sensor. So when you go into the devices page on the app, you can see here, you can say what location it's in. You can choose what the control is. Now, if you can, what you get in that is the option for relay or pilot wire. Pilot wire is not going to work for you, so it's always going to be set to relay. And then you can choose the sensor value. So here it's set as a 15K. That's not supported. You're only ever going to be using at this stage, until we've done some more testing on third-party devices, you're only ever going to be using the 33K sensor. Once that's set, you then get more feedback. Now, I've just set this to be 33K. I've not actually connected it, which is why I'm not getting any temperature feedback. Then that's why we've got that red triangle. But you can see then once you've assigned, or once you've told it that there is going to be a sensor, you then get to choose what the upper and lower temperatures are. Right, so that's the end of my bit that's sort of been planned. What I'm going to do now is have a look at the questions that are coming in. So first question I can see here is, how much power can we run through a smart plug? So the smart plugs are rated at 13 amps. So I think that's something like 3,250 odd, is it? Watts. So essentially anything that's the biggest load that you're going to get on a 3-pin BS1362, is it, plug, you'll be able to run through that. It does have overcurrent protection, so if you try and run something that is too powerful, it will just turn itself off. So I did a little test to see if I could run an immersion heater through it. And you call for heat, the thing turns on, it detects there's too much current, and it just turns itself back off. So it doesn't like trip anything. There's nothing to reset. It's just it detects that there's too much load, and it will prevent you from drawing that through it. So yeah, anything up to 13 amps is fine. If you do want to run an immersion heater on it, you can do it, but you'll just be using a third-party relay. So I've got a little rig here where I've got a third-party relay that is connected to the load side of an immersion heater. The coil side of that relay is what's being driven by the smart plug. So I've added a smart plug to the system. I've called it immersion heater. You flick it on. All that's being run through that is the coil of the third-party relay, and I think it's something like a 30-amp relay that I've got driving the immersion heater. So that works quite well. Bit convoluted. We might have a solution coming for that next year, or certainly on the roadmap for the product. I think is is a load switch, but you just have to watch this space to see when that's going to be available. But you can sort of do that as a workaround at the moment. 200-watt tail rail heater would be absolutely fine. You can do that. You would probably the thing with tail rails with the electrical heat switch is the electrical heat switch is the device that you would use if you want to run a tail rail. That's what we would market it as. If you want to run a tail rail, you would use the electrical heat switch. Because you're putting towels on it, obviously you're covering the radiator, and it's still a room stat that's going to be driving it. So you tend to find that you have to manipulate the room stat if it's a small tower rail, because it's working off of ambient temperature in the room. You may need to set that higher to compensate for the fact that it's being covered by towels. So that's a little bit of trial and error. Again, the load switch, when and if it comes, is probably going to be something that's a little bit more suited to a tail rail where you just want more on-off control. You don't really want the temperature sensing, but certainly if you've got a panel radiator, you're going to want some temperature feedback on that. So let's have a look. There's another question here. Just to clarify, a house with RADs, hot water tank, and underfloor heating would only run on a kit 3. Does the underfloor heating strip include any room stats, or do you need to buy them separately? Right, I'll do this in reverse order. So you buy as many room stats separately as you need. So the underfloor heating controller just comes as a controller. So you would buy as many stats as you need zones to run on that. Bearing in mind that you're going to need a hub as well. So you're going to get a room stat in whatever hub flavor you buy. A house with RADs, hot water, and underfloor heating would only on a kit 3. Not necessarily. So again, it depends how you want to wire it. So if you want to use the relay in the hub to drive the motorized valve, say for the underfloor heating, then you're going to have say radiators on channel 1. You're going to have the tank on channel 2, and channel 3 will be your underfloor heating motorized valve. You could do it that way, in which case you would use a wiser kit 3. You're still going to be having the underfloor heating strip, because you're going to need something to manage the thermal actuators. So that's one way of doing it. But you could just as easily do it on a kit 2 if you use the interlock on, that's this bit here. Let me show you that. That's this bit that I talked about here, the interlock. That's those terminals there. If you use those, then you could use it on a kit 2, because you would have your terminal, say, or the heating channel for so central heating on a kit 2 would go out to your radiator motorized valve. Hot water on, which would be terminal number 3, that would go out to your hot water motorized valve, or by your cylinder stat, obviously. And then you would be using the interlock on the underfloor heating controller to drive the motorized valve for the underfloor heating controller. So you could do it just as easily on a kit 2 or a kit 3. The only one you couldn't do it on is a kit 1, because you haven't got the hot water channel there. But it's really just down to you how you want to how you want to wire it, whatever's easiest for wiring. If you buy a kit 3, you've covered all the bases, but they are a little bit more expensive. But then you do get 2 room stats in there, so it sort of swings and roundabouts. It's whatever comes out to be most cost effective, I guess, at the end of the day with that. Right, there's a question here about, is there going to be a time when the room stat can control both underfloor heating and RADs, or are we going to be stuck with them being separately controlled? Well, as it stands at the moment, you're dead right, they are separately controlled. I've not seen anything on the roadmap to suggest that you can merge things together like that, but momentum is sort of growing on that. I am sort of hearing it. So it's stuff that we can feed back into the development team. And if you've got a scenario where you really need that to do that, then it'd be really good to hear from you and get some more details on that, because we can feed that back into the dev team, and that can sort of shape what gets onto the roadmap as suggested feature improvements. So it's at the moment we're sort of stuck with it, but I can see why you might need that, and also things like having multiple electrical heat switches in the same zone. So you might have two separate zones, or two separate heaters that are miles apart from each other, but in the same zone. You don't want to be running cables to them. You might want to group them together. At the moment you can't do that, but I can sort of see why you might need to. So again, if there's a need for it, and we hear about it, it can shape the future, the development of the product. So that's sort of where we are with that at the moment. Right, last sort of 30 seconds from me. So if you've got any more questions, get them in now, because I'm sort of done. Last thing I will mention is, I'm sure you're probably all aware of the 9 Degree shop, and if you're all going to be 9 Degree Network members, so you've got the priority shop there, and you've got the online training. It's well worth having a look on the shop. The shop has got some good deals on it at the moment. It's where you can get valve bodies as separate, so auto balancing bodies and normal bodies as separate. You can pick up the temperature sensor there as well for the underfloor heating, as well as some really good, really keen pricing on, as it happens at the moment. And I didn't plan this, but it's certainly topical. The 40% off is actually on what we've covered tonight, so it's a really good time to buy that. I couldn't have got that any better if I'd actually planned this. You've also got some deals on the bundles there. But also have a look, if you haven't already, at the know-how. So this is where all the training modules are, and I'm afraid it is predominantly me going on about stuff, but there's some good stuff on there. New Digistat TRVs, auto balancing valve. That's the latest one that we've put up there. So if you've not played with that yet, have a look at that. There will also be loads more of this coming next year. So there's going to be a lot more fresh content. We're also going to be doing some traditional stuff, fault finding. So as well as wise. I see there is one last question that's come in. Just, I've got a room with both. This is picking up on why we would need them both together. Got a room with both purely because it's a Victorian house with massive single glazing. The more heating surface area was needed. Yeah. So, and again, that I can see that is a reason why you may need that. It's something I guess we haven't considered from a development point of view, but we can certainly get that in, and as a suggestion of being how you can start merging things together. So not there at the moment. No visibility on when or even if that will get in, but most things like that tend to, because it's, as the more momentum it gets, the more sort of buy-in you can get from the engineering to make it a future upgrade. Right, well, that's it from me, guys. Thanks for joining me. It's always been a pleasure. It's been a good year. Thanks for your support on the channel. Have a good Christmas and hopefully some time off, and hopefully you're not going to be snowed in. You can get out and about. I'm going to be back, I think, sometime in January. I think it's sort of mid-January. We need to sort of get back to work and work out what we're doing. So you'll probably be hearing from me in mid-January with, I think it's going to be like a bit of a roundup of 2022, and answering the questions that you've been asking. So it's going to be a bit of a customer service mashup. So I think that's what you've got to look forward to, sort of mid-January when we come back. But have a really good time. Thanks for your support, guys, and I'll see you in the new year. Catch you all later. Have a good one.